In this section, we will discuss electrolytic cells and what is called electroplating. That means by passing electricity, you can plate different metals on another metal. Electrolytic cells force non-spontaneous reactions to take place. And this is used for metal plating and also separation of metals. Now, one of the reactions that I'm showing you here is the reaction of gold 3 plus ion. When it receives 3 moles of electrons, it's converted into gold solid. So right hand side is the solid. So that gets deposited on a metal. So the question is it going to be a cathode or anode where you can deposit gold? By looking at this reaction, you see that this is reduction reaction. Red cat reduction is cathode. So in other words, you must use a cathode side, whatever metal you want, to have a deposit of gold. The other point that I would like to make here is the following. If I have a number of different ions present in the solution and you are passing electricity through the solution, so obviously you'd be thinking in terms of competing reactions. All of those ions could be competing for receiving electrons. In those situations, keep this in mind. The ion with the largest reduction potential will undergo reduction because that's the best receiver. So best receiver is going to receive electrons. And the smallest reduction potential or best group to get oxidized is going to give up electrons. I mentioned before that your car battery is a voltaic cell. So basically it generates electricity spontaneously. However, if you want to recharge it, you need to force a reaction happen, which would be the reverse reaction, to take place. So in other words, reverse reaction is not spontaneous, and for that you need to force it to happen. When your car is running, that recharging happens. Same is the case with bike. Electrolysis of sodium chloride. Now, here we're showing you how we can get from molten sodium chloride, metallic sodium, and gaseous chlorine. We often use the word molten. Molten means it's the melted liquid. It's not aqueous solution. It's not water solution. So basically think it this way. If I have a sodium chloride with the table salt and there is no air inside, it's a vacuum, and if you keep on heating it at a very high temperature, sodium chloride, which we know as a solid salt, is going to melt into liquid, and that's molten. That molten sodium chloride would have sodium plus and Cl minus, and so sodium plus, as you can see here, sodium plus is going to absorb electrons because you have a voltage source attached to it, and you are attaching the end which is pumping electron in that direction. So in other words, the negative end of that cell would be attached to this end of the electrode, which would be acting as a cathode, and sodium plus is going to absorb that electron, becoming sodium. On the other side, Cl minus is going to give up electrons, and that's how eventually it would combine with another Cl and becoming Cl2. So this is how we can get sodium and Cl2 by electrolysis of sodium chloride, which is molten sodium chloride. But if you try this in water, it's not going to happen because there are competing reactions where water is going to take part. Let's go over number 91, page 871, Brown-Lemay book, 12th edition. The question is, chromium 3 plus solution is electrolyzed using 7.60 ampere of electricity. What mass of chromium is plated out after 2 days. So basically they're asking for how much chromium, gram of chromium you're going to get after passing electricity for 2 days. So let's do this problem. I'll begin with what is given, which is 7.60 ampere. And we know that ampere is nothing but coulomb per second. So let's write down that as coulomb per second, because that way you can think it better. So this, instead of ampere, I'm going to write down coulomb per second. Coulomb is the unit of charge. Okay, so let's start my dimensional analysis, starting with 7.60 coulomb per second times, I need the number of seconds. It's the time when you passed electricity. So that's 2 days. Let's find out how many seconds are in 2 days. So let's write down 2.00 days, 1 day, 24 hours. So 1 day has 24 hours, and 1 hour has 3600 seconds. So that gives me 1.73 times 10 to the power 5 seconds. So I need that second now, and so let's use a different color here so that you know which one I just calculated. This is the just calculated value, 1.73 times 10 to the power 5 second. That's the time when this electricity was passed through the solution. Now second would cancel out. Second per second would cancel out. That gives me coulomb. And we know that 96,500 coulomb, this is called 1 Faraday. That's coulomb. That's charge of 1 mole of electrons. So 1 mole of electron on the top. So coulomb would cancel out. Now I have a mole of electron. Now look at the reaction. 3 moles of electron is going to plate out 1 mole of chromium. So that's what we're going to write down next. 3 mole electron, 1 mole chromium. Now we are almost done. Now mole of electron cancel out. This gives me a mole of chromium. From periodic table, you know how to go from mole of chromium to gram of chromium. Keep in mind mole-gram relationship. Look at periodic table. I often say MGP, mole-gram periodic table. So 1 mole chromium, and I get, look at the periodic table, and it's 52.0. So if you do the math, make sure you do it independently rather than just going by my number. 236 gram chromium. And that's the answer to this question. This is part A. In part B, 91B, the question is what amperage is required, or what how much electricity is required to plate out 0.250 mole of chromium. So let's write down what they want. They want to plate out 0.250 mole chromium from chromium 3 plus solution in a period of 8 hours. So 8.00 hours. So they want to pass electricity for 8 hours, and they want to get 0.250 mole of chromium. It's always a good idea to start with what is given. So let's start with 0.250 mole of chromium. Again, I need to get information about electron because they're asking for ampere. which is nothing but coulomb per second. So it needs to get coulomb out of this mole of chromium. Now, how do I get that relationship? Again, look at the reaction. Each mole of chromium, in order to get plate out 1 mole of chromium, you need 3 moles of electron to pass through. And we are going to make use of that. So 1 mole of chromium at the bottom, is plated out when you pass 3 moles of electron. Now I need to know about coulomb, because that's how I can get the ampere. So 1 mole of electron, now let's use a different pen, 96,500 coulomb. 500 coulomb. So 96,500 coulomb would be there. Now that gives me, let's write down the value now, 7.24 times 10 to the power 4. I try to do problems in segments like these, that way I can think better. Now I got coulomb now. I need to get coulomb per second because that gives me ampere. So how do I get second? Well, they gave 8 hours. So let's change 8 hours to second. So let's write down 1 hour (3600) second. So this gives me 2.88. Again, you should double check. 2.88 times 10 to the power 4 second. So I got now, let's separate these two steps of calculation. The first step gives me total coulomb. Second step gives me total number of second. So in order to get ampere, you have to divide coulomb by the second. So let's do that. 7.24 times 10 to the power 4 coulomb divided by 2.88 times 10 to the power 4 second. 4 second, and that gives me 2.51 coulomb per second, or 2.51 ampere. And that's the amount of electricity, that's the electricity you need to pass through for 8 hours to deposit 0.250 mole of chromium. So this is my answer. Here we're going to discuss problem number 92. 92A is very similar to 91A. So if you understood 91A, try yourself and it should work out. In 92B, again, these are all similar problems, but your dimensional analysis method that you are going to apply, I mean, that would result in different answers depending upon what they're asking for. Like in 92B, again, you have molten magnesium chloride. Molten magnesium chloride means it's a melted liquid where magnesium chloride is going to get separated into Mg2 plus 2Cl minus. Now Mg2 plus is going to receive 2 moles of electron converting into Mg solid. So that's extremely important reaction for us. Now you can think better if you write down unit of current or electricity as coulomb per second. Ampere is same as coulomb per second. So write down this here as coulomb per second. Okay, now with that in mind, let's start this problem. It doesn't matter whether you start with 3.50 coulomb per second or you start with gram of Mg. You'd get the same answer if you pay attention to the units. So 25.00 gram Mg, so I'm going to start with that. 25.00 gram mg. From periodic table, we find out 24.30 gram, 24.30 gram of mg is in 1 mole of mg. So basically this gives me mole of mg, from gram of mg to mole of mg. Next step, so let's draw a line here. We see here mole of mg, 1 mole of mg. Look at the reaction, second reaction that I've drawn. 1 mole of mg involves 2 moles of electrons. So let's write down that 1 mole mg to plate out needs 2 moles of electrons. And we know that 1 mole of electron carries 96,500 coulomb. So if you do the math and you get 1.986 times 10 to the power 5 coulomb. Okay, so that's 1.986 times 10 to the power 5 coulomb that is needed to plate out 25 gram of magnesium. But the question is not asking for coulomb or electrical charge, it's asking for current. So the current is coulomb per second. So I already got the coulomb. I'm sorry, the question is asking for time, not current. Current is given. The time in minute they're asking for. So what I have now is coulomb. I also have coulomb per second. Let's look at both figures. 3.50. So let's write down again a line here to separate this. 3.50 ampere is same as 3.50 coulomb per second. So obviously we need to use these two numbers. Let's 1.986 times 10 to the power 5 coulomb and 3.50 coulomb per second. We need to use these two information to get second. Once I get second, I can get minute. So obviously, if you do the following, you get second. 1.986 times 10 to the power 5 coulomb times coulomb at the bottom, second on the top, and I do know this information, 3.50 coulombs per second, because this gives me the ampere that they're passing through. Now that's second, and we know that 60 seconds makes a minute. 60 seconds make a minute. And this gives me, make sure you do the problem as I'm doing it, 9.455 times 10 to the power 2 minute. That's what I got, and I can round off to 9.46. I'm sorry, 946, because we're multiplying by 10 square. So 946 minute. So the answer to this question is 946 minute. So you basically need 946 minutes of electricity of 3.50 ampere to be passed through in order to plate out 25 gram of magnesium.